And so in this lesson, we are focusing on now our exterior theorem with our triangles, so exterior angles. And so here, for example, actually go ahead and pause the video and get the angles on your own, and then we'll talk about what do you notice. And here we go. So the measure of angle 1, notice linear pair, right? So you should have gotten here 88 degrees. They were all even angle 2 was a linear pair. So angle 1 is 88 degrees. So then angle 2, you should have gotten 57 degrees because again, linear pair. So now 3 and 4 were both missing. However, now you have two angles inside of your triangle, right? So then you could just use the interior where they add up to 180. So here, so far you had 145 degrees, which means angle 3 is 35 degrees to add up to the 180. Then you can find now the measure of angle 4 because again, the linear pair. And this you end up with 145 degrees as well. So now, what do you notice about the relationship with the interior and exterior angles? So the first thing I noticed is when we added these two together, you got 145. This was the same as this exterior angle here that these two angles are opposite of. So this is opposite of these two angles. So here, what if I added these two angles that are opposite from this exterior here, these two here? Well, here you add these up and you get 123. Well, what do you notice? 123. So let's check it. I'm going to erase this here. So from 92 degrees, not the one here, the angles that are opposite from it. So 3 and 2, or what they like to use is the term remote. So angle 3 was 35 degrees. Angle 2 is 57 degrees. When you add these together, you get 92 degrees. So notice how they match. So the two angles that are the remote from the exterior or opposite from the exterior angle will always add up to equal the exterior angle. And that is the theorem, and that's what we're going to be using today. So like, for example, you could technically add these two angles that are given to you, right? 30 and 14 to get the third angle, and then subtract from 180, right? And you will still get what x is equal to. Or these two angles, notice, are remote. They're opposite from the exterior angle that we are looking for. So all we have to do is just add them up and get 44 degrees. So same thing here. Notice again, this exterior angle is these two are remote. They're the opposite, right? Not the linear. So all we have to do is just add them together and you do get 111 degrees. So now here, you're just working backwards, right? You're given the exterior. We're given 31 and you're looking for the missing. So if we're looking for 31 plus what is going to give you the 93 degrees, right? Because that's your exterior. All you have to do in this case is subtract 93 minus 31. And that gets you 62 degrees. So again, 62 plus 31 is 93 degrees. So again, this is just kind of getting used to that idea of the adding the two to equal your exterior angle. So now how are we going to set up 2A here? Well, this is your exterior angle. This is the linear, so we're good. And these are the two opposite, the remote, which add together to equal the exterior. So 2x plus 3x is equal to 120. And now we're just solving for x. So 5x is equal to 120. So when you divide, you do get 24. So x is equal to 24. So go ahead and pause the video and let's see how you do with at least solving for y, but then notice what the question is asking for. And here we go. So here you're given the exterior angle, right, of 146 degrees. So now here, you're not given the linear, you are given the two remote, the two opposite angles, which add together to equal your exterior. So again, 5y plus 3 plus 4y plus 8 is equal to 146. Now just combining like terms here, 9y plus 11 is equal to 146. So now we can go through and solve. So here we go. After subtracting 11, right, from both sides, you get 9y is equal to 135. So when you divide it, you should get y is equal to 15. So is this our answer? No, because we're looking for the measure of angle B, which is here. So 4 times y, which is 15, plus 8. So the measure of angle B is 68 degrees. And so now here, notice in example 3, we have no values, right? It's nothing but just our binomials here, right? Our expressions with x. So it's the same concept though. Here's our exterior angle. We're not given the linear, but you are given the two remote, the angles that are opposite. So again, adding these two together to equal the exterior. So again, 9x plus 16 plus 6x plus 15 is equal to 19x plus 3. Now just combining like terms here, right? 15x plus 31 is equal to 19x plus 3. Now we need to make sure, right, to gather our variables. So I'm going to subtract 15x from both sides. And 31 is equal to 4x plus 3. Now notice we're just solving a good old two-step, subtracting 3 from both sides. You get 28 is equal to 4x, and x is equal to 7. Is this our final answer? Yes, because we're just solving for x. So again, it's all the same concept, right? So making sure to add those two interior if they are the remote, the opposite from your exterior. So go ahead and pause the video and try 3B and 3C and make sure that you answer the question that's being asked. And here we go. So for 3B, you needed to add the two interior because they were remote interior from your exterior angle. So 5x plus 2x plus 6 is equal to 8x minus 11. And then combining like terms, 7x plus 6 is equal to 8x minus 11. Then make sure to gather your variables. So subtracting 7x from both sides, 6 is now equal to just x minus 11. So when you add 11, you get x is equal to 17. And that was your final answer because you're just solving for x here. 3C, same thing. Add these two together to equal the exterior. So 7x plus, well, 60 plus 5 is just good old 65, right? Is equal to 20x. Now, this is not here subtracting 65, right, because of the 20x. So gather the variables, subtract 7x from both sides. 65 is now equal to 13x. So when you divide x by 13, both sides by 13, you get x is equal to 5, but you're not done. You're looking for the measure of angle BCD. So BCD. So you are looking for this angle here. So 7 times x, which is 5, plus 5. You should have gotten 40 degrees.